Hi, everyone, and welcome to my third experimental technology presentation. Today's focus is going to be on the maker movement, and as I was exploring this, I really felt interested in actually two tools. One is called Scratch and one is called Codester. So Scratch is a program for interactive stories and games and animations. It's really cool because there's a whole online community built around it. It promotes 21st century skills among students. It was created by the MIT Media Lab for those in the lifelong kindergarten group, and it's free to use. So that was definitely a bonus. The other website I stumbled upon as I was looking for a coding website was called Codesters. This really focuses on coding in the classroom as like a curriculum. It's easy to use because it's drag to text. So as you can kind of see here on the screen, they have all of the authentic coding language, but you'll see later on when I show you a demonstration of what I found that it's really simple to use. It's just kind of drag and drop, and that's when it turns into this language. They also have an LMS system, so the teachers can create and manage student projects there. So something definitely for like a classroom coding course. And there's 3 phases to project-based learning lessons that are pre-made, ready to go. Students just have to have their class code and join their course, and they can go and do those. And it's free. There's also some paid options as well. So the purpose of this tool was to inspire students into the maker movement by providing coding opportunities for inside and outside the classroom. I know that I had students participate last year in an hour of code, and they did not want it just to last 1 hour. They continued coding for the rest of the year whenever we had free time. So that was kind of really inspiring that it can happen anywhere. So long as they have their devices, they can code wherever they are. And students act as computer scientists and programmers through these fun and easy platforms. Again, I'm focusing on 2 of them because there were different features in both that I really enjoyed as I looked for a way to implement them into my classroom. So with that being said, Scratch is really cool to use because it has simple language and it's user-friendly, which I'll show you in my demo after the PowerPoint. But it's very easy. It's just simply drag and drop. It's almost like tiles, so it makes it super easy for the kids to understand what is going to happen to their animation. There's a community, so there's projects and studios. People can work simultaneously on a coding program for their animation. They can share worldwide. It is really, really cool. There's tutorials to get started, which I thought was great, at least for me as a novice, because if I didn't know how to do anything, there was always a bar at the side for how to do whatever I wanted to do. I couldn't figure out how to get my image to rotate. I couldn't figure out how to change the background. There were step-by-step tutorial guides there that were videos, and they were great. And that's also what I meant, the step-by-step creation on each page. Super helpful. For Codesters, there is a graphing overlay, which is actually why I started looking at Scratch and then I switched to Codesters because I wanted the graphing option, which I'll tell you about in a little bit. There's text and shapes that you can create. There's the authentic coding language, like I mentioned before, that it's simple to use because you drag what you want to happen, but then it creates that authentic coding language so students can kind of see what it looks like if they were in real time doing real coding. And there's also mathematic applications, specifically transformations. You can have students flip, rotate, translate, and dilate images, which are all types of transformations in geometry that students see in 8th grade and above. So that was really cool that you could have students manage that all through a coding system. So how does this support the maker movement, or kind of what's the big idea here? So coding overall is sparking interest in students. It gets them interested in computer science careers, which is a desperate need in our world as everything moves more digitally and not as many students move into that field. There's going to be a deficit, and we want to kind of promote students that this is fun and it's not as complicated as you think. It opens new domains of knowledge and it addresses the gender gap. Most coders and computer science folks have been deemed like the white nerd male, but these programs are so simple to use and so student friendly that anyone can do it, that hopefully it addresses how people see others in these careers as not just white males, and that it can be women, it can be people of color, it can be pretty much virtually anybody, because there's so many tools out there to use right now. Anyone can code anything right now. It leverages parent involvement. This is something, kids can make for their parents, parents can make something for their kids, they can work together on something, especially if you're on Scratch, you have that community to work together. So it gets parents involved with the kids learning, provides momentum for computer science curriculums, especially like we saw with Codester. Has its own curriculum, so that's super helpful. And it helps students meet the ISTE standards. And all of these notes here come from an ISTE article, which I'll show you later in the presentation. So really helpful. This is a video about what schools don't teach, and it's really inspiring to me. And I'll let you watch it on your own through this PowerPoint, but it talks about all these different people in the computer science field, from Mark Zuckerberg to Bill Gates, to Will.i.am. All these people have been coding, and they talk about how they started very simply and found that it was fun, enjoyable, and easy enough to do, that they worked their way up to obviously being masterminds in the field. So for me personally, what I hope to get out of this is a graphing assignment for my students using Codester. Again, I started looking at Scratch because I knew about Scratch previously, or I had heard about Scratch previously, but Scratch didn't have all the features and abilities that I wanted. Therefore, I found Codester, so I'm going to use Codester for my projects. But I worked with Scratch, so I also wanted to talk about Scratch. It's going to be a real-world application for students to understand the importance of the coordinate plane and graphing. All of coding is set on a coordinate plane. So for me to miss this opportunity to teach students not only about the coordinate plane, but coding, and mesh the two together and say, look, whenever you do code, the surface you're on is a coordinate plane. I couldn't miss that opportunity for my students to bring something that was so real world into my classroom and into my content. And I want students to exercise transformation, learning new math and vocabulary in a fun and creative way. So that's what I hope to get out of this project that I'm going to do with my students. So some drawbacks and recommendations. Since I'm very novice to coding, I don't have as many recommendations and drawbacks, just because to me everything seems great right now because it's all so new and I'm loving it. But for Scratch, I wish it had that graphing overlay. Again, that's why I had to go to Codester. Also, I wish that they also had the option for viewing the coding language, because for Codester, it's like I said, it's easy to use and you get that language, whereas Scratch is still those tiles. And sometimes I wish students could toggle back and forth to see what they're really doing or what that real code language looks like. For Codesters, I wish there were, our Codesters, the drawback is that there's that more complex language. Kids may not understand it, although I think it's really great to see. And there's also limited viewing space. I think that's something that I would want to change to create a pop-out feature. Scratch has a pop-out feature, Codester does not. And so it kind of only leaves less than half of your screen available to see your animation. So that's something that I would probably want to change. So without further ado, I want to show you a couple of things that I have made through my experiments. So this is one of the scratches that I made. And I started out using the coordinate grid because I needed to understand where I was placing my coordinates. But for the purpose of my presentation, I'm going to actually pick a different backdrop, something more appropriate, might be the basketball court. And here, I'll go back to my script. And back to what I did. So when I click the flag, it's going to bounce my ball. And I also had to adjust the time. That was something that I found trial and error with, how long it was taking. Like I said too, I used the overlay of the graph so I could figure out what coordinates I wanted to be on. So here we go. So that is my bouncing basketball that I made through Scratch. Something very simple, took me almost all day to do. Meanwhile, on the coordinate plane, this is what I found on Codesters. I did not make this, this was pre-made, but this is really what inspired me to move from Scratch to Codesters, because with Scratch, I really wanted my students to use the coordinate plane, but I couldn't find a way to overlap my coordinate plane with that basketball field. And I want my students also not to be using something going from counting by hundreds. That was a little too much. So I found this on Codesters, and here is what somebody has programmed. Like here is the plain language, but again, simple enough. All you have to do is click and drag what you want done. If you want it to wait, you click and drag it over, and it will do that for you. But here's what someone's made: a snowman on a coordinate plane backdrop. The pen is down. That's why you're seeing the lines, because it will drag and outline the course. And so I'm going to use Codesters instead of Scratch for this reason, that it has the graphing overlay, that the pen can be down and it can trace the course, because I want my students to graph points, reflect points, because that's part of our state standards. I also want students to be able to identify, coordinates. So that's why I'm going to use the coordinate plane. This was kind of my inspiration to get to there, as I, noted on Scratch that I have to pick one backdrop or the other. I really, really want the coordinate plane, so that's why I'm going with it. So as you can see, Codesters, Scratch, very similar tools, super fun to use. You could play all day. You can add sound. You can add, different sprites. That's what the images are called. The possibilities are truly, truly endless. And here, like I said before, are the 6 reasons that coding is needed in the classroom. I will cite this, put this article also up on my website. But overall, the importance of the maker movement and how coding impacts students' lives is really important. Those fields are going to be in a deficit, a dire need of employees in the computer science field, from medical to industrial. Computers are where our entire future is. So students need to learn to code. That's pretty much the language of our 21st century. So these are some really cool ways to get students starting in a very non-threatening and friendly and fun way. So that is my presentation, my tech for the week. So I hope you enjoy learning about Scratch and Codesters, and definitely go out and try one of them out, because they're super fun, free to use, and students love them. So have fun.